Greetings. This is Frank Kutka, the Sustainable Agriculture faculty member from College of Menominee Nation, and also a private seed saver here at home. And I'm going to talk to you today about reconnecting with northern flint corn, a little bit about its background and what it is, how people relate to it, how it grows, issues you might find when growing it, and all the fun that comes along with it too. So first, what is it? What on earth does it mean to have flint corn? So flint is a very hard stone, as you're probably well aware. It's used to make tools um, and to start fires. Flint corn is named for the very hard kernels. The kernels are rounded, unlike some of the other seeds that you will see, and they're very, very hard. If you took some of the dry seeds and tried to break them with your teeth, you might very well break your teeth instead. It's not recommended. Flint corn does have some of the characteristics of flint stone. You can see it's somewhat translucent, quite shiny, absolutely beautiful grain. In order to cook the stuff, generally people had to grind it. If you didn't eat it while it was still in the green stage, immature like sweet corn, you would have to grind it, and it's quite hard to do. It'd be quite a lot of work. A lot of times people actually toast it first before grinding it just to soften it a little bit. Flint corn seeds come in this magnificent yellow here, but also lots of other colors. You will see blues, reds, whites, various patterns. There's quite a lot of diversity in this race of corn. However, it's not just hard. This racial type also includes some other corn textures because of important mutant genes that are present in the species. And one of those is the flowery gene. And so if the flowery gene is present, we now call this flower corn, although it's basically still the same racial type as we'll describe here shortly. Flower corns are soft. They're very easy to grind. You can actually break those kernels with your teeth and not risk too much dental damage. And these types are used for very fine grinds of cornmeal or for soups and hominy. Some of these are also quite colorful, as you can see, bringing delight to everyone who ever picks them and eats them. Although, to be honest, multicolored corn like this, although beautiful to behold, makes a somewhat off-colored cornmeal. If you have all these colors all together, you get this sort of a grayish tint to it. Doesn't change the delicious taste whatsoever, but people like what they like, I guess. Flint corns can also be sweet corns. Sweet corn is a result of a single gene. The old type here is just the SU1, and if it is the double recessive form, you get these wrinkly kernels when they are dry. And they're wrinkly because the starches don't set up properly, and this also means then that they stay sweet longer and are more tender. So highly regarded for eating in the green stage while they're still immature. Although, if you've never tried it, cornmeal made from sweet corn kernels is quite delicious. Flint corns can also pop. And this is one old variety called Spanish popcorn. Don't really know why. It's from the Great Plains, I believe. But it's an 8 to 10 road popcorn. It's not the best popper ever, but as you can see, we still have very flinty kernels. They're a little bit small, which helps them pop better. And translucent and white in this case. And so with the right genes and the smaller kernel size, sometimes you can get the flint corns to pop so that they'll make a reasonable popcorn. Popping them is probably what happens when you toast them a little bit anyway, and I believe that makes grinding much, much easier. No doubt you can eat it in a lot of other ways too. Now across the board with all these various textures, which are sometimes used to suggest completely different kinds of corn, the northern Flints have the same basic form, and that's why we lump them all together. They tend to be fine-leaved. They tend to be leafy, with leaves that arch and bend downwards. Leaves oftentimes kind of narrow. The stems are fine and thin. The cobs are thin as well, frequently long and thin with just 8 to 10 rows, although sometimes they'll have 12 or more rows of kernels. Kernels tend to be about the same, kind of round, moon-shaped. They don't have any dents on them. They're not wrinkly generally, unless they're sugary. As you can see on the right, there's a classic northeastern type of flint corn. They have extra stalks we call tillers, and everything else I just explained is shown there. We have many long, thin leaves, very thin stalks compared to what you see from commercial corn. Also, if you notice from the old black and white drawings, a lot of times the ears are slung kind of low on the plant, although the green corn on the right, obviously we've got ears right up in the middle, which is a nice place to try to get them out of the way of raccoons if possible. Here are tillers quite clearly. Right in the middle of this photograph are two plants. So they're sort of one behind the other, but along with the two main stems, we also have two extra side shoots from each of those. So it looks more like a bush. Tillers don't harm production, but they don't always necessarily help it. Still, it's a common feature of this race. It's very, very common to see plants with extra side stems, especially if you give them lots of room, if it's a low planting density. The taxonomy of this kind of corn has been a little bit messy over time. Clearly, it is Zea mays. There's no doubt about that. This is corn just like all the rest. And there are two races kind of broken out of our northern region here in Turtle Island. The northern, or sometimes eastern, or sometimes northeastern flints and flowers, as they are sometimes called. And then some people will break out a Great Plains flints and flowers separate race. All of them across the board have these thin stalks. They don't have a lot of prop roots. They have relatively low ears. They tend to have tillers. They also tend to have flag leaves, which I'll show you momentarily. They differ by area of adaptation. They differ by height and the proportion of 12-row ears. Generally, you see more 12-row ears as you go west and fewer as you go east. But, you know, what do we say about the other kinds? Gaspé and Micmac and other mini varieties that are, you know, scarcely more than 2 feet tall. Are they really in the same race as some of these other flint corns, which will grow to be 8 to 10 feet tall? You know, what about the popcorns? How do they fit in to our region? Because they do grow here and they've been here for thousands of years. And of course, a reasonable question for any biologist is, does race really exist anyway? It's kind of more of a conceptual thought in our heads. Reality doesn't always fit this when we get out there. So although it's sometimes handy to talk about races, it's not always biologically relevant. And as I just explained, sometimes it's hard to really draw the lines. One of the traits we rarely see in the northern flints are these prop roots. Now, prop roots are very, very useful. It's a great trait. Um, these are adventitious roots that come out of the nodes above the soil, and they will reach down towards the soil and root once they get there. This can help provide structural support to the plants. Don't see a lot of this development in northern flint corns, although some varieties will make some. As I explained, tillers aren't necessarily bad. On the left, we see a plant with 2 tillers. Uh, it's kind of cute in its own way. Lots of greens if you're going to feed the plants off to animals, surely. But there is a downside to tillers that I would like to explain, and that is that it's not uncommon for an ear to form at the end of the tiller. Some tillers are fully male and they'll just have a little mini tassel at the end. Some are fully female and will just have an ear, and some will have a mixture of the two, hermaphrodites. Oftentimes these will be bared to the air, and that means insects and birds can get at the developing seeds, and if they don't demolish them first, the added weight of an ear developing at the end of tillers can oftentimes encourage them to fall to the ground as we get into fall. So that is not beneficial. So exposed ears at the end of tillers is a problem with tillers in some varieties, and something to watch for. Tend to select against personally. But you of course can make your choices. Here's a photograph of sweet corn. A lot of sweet corns, have been improved. They have lots and lots of rows, but what's common in sweet corns, along with the northern flints, which are part of their heritage, are these flag leaves. At the end of each husk on all of these ears, you can see an extra place where the husk turns into a short leaf. These are called flag leaves. They're perfectly fine for the plant if you've got enough water for them to grow. They will also, produce photosynthates and help support development of the ear and the plant as a whole. They are a pain when you're trying to do hand pollinations, but otherwise no problem there, and interesting to see. If for some reason the rest of the leaves are damaged, having this backup set of leaves appear later on will be helpful to get the plant to finish producing some sort of seeds. It's kind of a backup plan, if you will. Here's one of the mini flints. As you can see, you got larger corn in the background, and this in the front here is really about 2.5 to 3 feet tall, with little ears, as you can see, scarcely 6 inches off the ground. And the ears that form are all about 3 to 5 inches long, with 8 to 10 rows. This is Gaspé flint from the Gaspé Peninsula in Quebec, north of Maine. A very, very early type of corn. Long, thin leaves, fine stems, narrow ears with few rows, flinty round kernels. Here is one of the many white varieties grown by the Haudenosaunee people from New York, Ontario, and Wisconsin. This is a very long-eared variety with white flowery kernels. Now, this is in the same race, ostensibly, but look at the size of these ears. Also, the plants are very tall. They have very long husks. Ears are very well up. Same basic characteristics of the plant as far as fineness of leaves, fineness of stems, the number of rows, but in many ways very, very different animal than the mini corns like the Gaspé. Absolutely delicious food, I must say, as well. So pretty much, across the board, tall or short, we're looking at plants with few kernels, and we tend to have these kind of rounded kernels, which are generally high in mineral content, generally high in protein content, generally high in oil content, make absolutely delicious food. That's a key part of it, and I'm sure partly why these were so popular as they were developed and used in this region for a couple thousand years. Now, there are other kinds of corn in the world, so I just want to point out that ours is kind of unique. Um, Here are some of the major races of maize that are recognized in Mexico. And you can spot, if you look fast, there are a few 8-row races. Most of them are not. The rest of the plant forms quite different generally from what we see here. And the adaptations of our local corn, which are also to our local climate, they germinate in cool soil. They don't mind wet, damp weather. Quite different in many respects from this homeland of maize. Northern Flints also differ from what you find in a lot of other locations. Peru has the secondary area of maize diversity. They do have a few 8-row varieties. They're quite different from what we have here. Plant forms very different. The ears tend to be shorter with absolutely gigantic seeds. Ours is very different from what you find in the Caribbean or the east coast of South America, like this Cateto types we see here, this nice orange corn with 14 to 18 rows. Just not exactly the same. So there's a unique, special thing here. It was developed in the Great Lakes, on the plains, and in the Northeast on the St. Lawrence Riverway. It is the local corn that was evolved along with the entire corn culture here in this area. So how did it get here? Well, there are many spiritual stories about its coming into the world. And so I will let people who are experts in telling and knowing those stories tell you about those. I will tell you what archaeologists and scientists have been finding in their work. So whatever you call this wonderful grain, whether it's maize or corn, wapaman, anust, mandaman, sara, noah, ishkim, mak, osh, wakmiza, kahati, kukuridza, it seems to have come north up through the desert southwest from Mexico. But it is a complicated story. It doesn't seem to have happened all at once. It took a very, very long time. And wouldn't it be wonderful to know about all the people who took part in this chain of passing seeds along and the lessons about how to raise it? So what else is there to know? Well, it seems from archaeological work that's got more and more fine in their keeping track of botanical details in their digs, that small amounts of popcorn appear to have come into our region about 2,500 years ago. It wasn't a big crop, but it showed up and people kept it. By about 1,500 years ago, things have changed and some new corn has come in, and perhaps with it some new information about how to grow it and also other crops. It's come in and joined existing crops because agriculture existed here for a very, very long while. Corn seems to have come into an existing agriculture and been adopted and adapted. The northern flints are evolved and chosen, become the common type, seen more frequently than anything else by about 1,200 years ago. It's a big deal. Interesting things were happening. Scientists recognized that something impressive happened here. Skillful cultivation and careful attention to the selection and improvement of variety were necessary for its development here. Hoy 1883. A lot of farmers, or I'm sorry, a lot of scientists aren't even aware of flint corns anymore. But people who are aware of them and know about them and have seen the diversity are, of course, impressed with what came to be. Also, recent genetic work suggests that within about 1,000 years of being in the area, the northern flint corns diverged from all other types of corn to be very, very distinct biochemically. When you look at the gene markers in the chromosomes of our local corns and compare them to corns from other places, they're off by themselves. It's a very, very unique type of corn. Now, here are some places where it's shown up in prehistoric locations. So before Europeans and writing, um, all over the place, as a matter of fact, but not in the deep south, not along the Gulf Coast, not in Florida, mostly to the north, which has led some to suggest that corn may have come from the desert southwest up onto the plains, up to the Missouri River, and then north to the Great Lakes, perhaps going south later. No one knows for certain. But it isn't a direct, easy chain where it came across the South first and then went north along the coast and up the Mississippi. It seems to be a little bit more complicated than that, although there's lots more to learn. Wherever it went, it looks a lot like this. And this. Beautiful stuff with great diversity, but highly selected. The corns of the desert Southwest are mostly not like our 8-row corn. However, there's more to it. It went farther north than the United States. So if you pay attention to what goes on in Canada, they have archaeological work and have found there has been an extensive and quite long-lived corn culture up in southern Ontario, right through the midst of the Great Lakes, and even beyond, all down the St. Lawrence Seaway, right to um, the Maritimes. Corn's been there for centuries. Perhaps not thousands of years, but at least centuries. And in all these places, we see the same thing, highly selected towards a mostly 8-rowed type. There's Stephen McCumber with just a killer braid of white flower corn. And again, we still see some diversity in colors in this area, although frequently people selected for pure colors. The USDA in 1936 published their yearbook and included a lot of recommendations from all of the state egg experiment stations and extension services. And for the northeastern states, they recommended quite a number of interesting varieties, some of which are still in existence, some of which are extinct so far as it's anyone can tell. So you see here Angel of Midnight, Ashmont Golden, Burwell Yellow, Canada Yellow, Davis Yellow, Golden Nugget, King Philip, Longfellow, Rhode Island Whitecap, Sanford, Sheffield, and some others as well that I would mention that are around and have been located. If you look around, the USDA does have some of these, and others do too. Seed Savers Exchange, some other organizations that sell seeds or share seeds, some small commercial houses sell some of these as well. Indigenous Seed Keepers Network has some of them. Northern Grain Growers. So you can find quite a diversity of flint corns, even though we've lost a lot of things since the advent of the Corn Belt Dent and then the subsequent advent of hybrid seeds, which really put the kibosh on a lot of our older varieties. In the Midwest, we find there was an active corn culture that's gone on for quite a long while. Also used northern Flint types. These are a few of the ridged gardens from Menominee country. Throughout the state, we had, this state, Michigan, several other states nearby as well, there were gardens with ridged beds. There are also gardens with mounds, much like you see practiced further east. And on these, they grew a variety of crops, including corn. Flint corns became very, very important to agriculture among immigrant communities, among the various indigenous communities that were moved or tried to escape ahead of the large-scale invasion of the continent. Everyone was growing northern Flints for a while, and quite a few of them were popular well into the early 20th century. So you can see here Sanford and Longfellow and Smutnose, King Philip, all being mentioned. Most of these, again, were replaced by the dent type, which you see in the upper left. Dent corn, I'll explain in a little bit, replaced most of these other ones because the very leafy, fine-stemmed corn doesn't stand as well, doesn't produce quite as much silage as the dent types did, and so those mostly replaced them in the major agriculture. However, among seed savers and those who kept their seed, obviously the northern Flints remained exactly where they were as a primary source of food. However, the story is more complicated than that. And recent archaeological work that has actually started to consider not only bits of plants in and around garbage dumps or in and around places where people cooked, but they're also looking at bits of corn that remain stuck to pots and finding tiny amounts anywhere that they might. And it turns out that corn was being cooked, at least, way up to the subarctic areas by 1,500 years ago. So as northern Flint corn is expanding across the region, it expands everywhere. It's just really getting moved and becoming an important part of food culture, way up into Manitoba and Ontario, north of Lake Superior, places where you'd never think of corn being grown now. Was this all through trade or was some being grown? I don't know. But it is interesting to see how important corn became. In the early 20th century, indigenous people were still growing corn quite frequently. A lot of people of every culture were actually still actively producing food. And that's largely changed as the century went on. But here is a absolutely beautiful set of braids this fellow has here at Cass Lake in the early 20th century. Here is a good harvest of corn in Kenora, Ontario, north of Lake of the Woods. So whenever it got there, Flint corn was still being grown. It is quite cold tolerant, although you have to have the right varieties with the right maturity. And, as people work to bring Flint corn back to some of the islands, obviously figuring out that maturity and the balance of heat needs and all the rest will be a key part of the process. But we know some of the varieties out there have the capacity to be pushed well into the north. This is the food that people were producing and may well produce again. Varieties recommended for the Midwest by the 1930s were not so many. Dakota White shows up in the Minnesotas and pearl white, whatever that was. Some other varieties we know certainly will do well here and were part of the scene at some point. So King Philip Longfellow, a Great Plains Rainbow, Salzers, Smutnose, the Italian variety Autofile, the Montana variety in Painted Mountain, all these are grown and people do enjoy them in our region. And the same group of folks again, both commercial and government and NGOs do have varieties that will work here in the Midwest. Many more that I am not aware of course, as we especially get into traditional varieties that people have maintained. As you go further west, you find a very strong corn culture was going on the Missouri River, and people moved north and corn with it. And so the Nueto, Hidatsa, and Sanish people, who all ended up in North Dakota over time, had villages based on agriculture and bison hunting, and then wild crafting of wild foods as well. This corn culture greatly influenced the development of European immigrant agriculture, as the Wills catalog on the side shows. Here in their 1919 catalog, honoring the memory of those villages and the people who grew these varieties, some of which were still being adapted and grown in the early 20th century. These gardens were frequently close to rivers, rarely up on a very dry prairie. And their corn varieties, given their climate and the time they had, became very much adapted to challenging dry conditions, challenging hot conditions. Many of the northern flints from the east, when you take them out to North Dakota or Montana, just fry in the sun. The tassels will fail. Sometimes the ears will fail. Sometimes the upper leaves will burn. That said, some of the Great Plains varieties, when you move them east, are extremely susceptible to fungus. A lot of them will fail, fall to the ground, and seem to melt before harvest even gets going. So local adaptation is important, and this is partly why finding the right parents for anything you want to do is a critical thing. Now, any plant can be a parent, but obviously, some of them are much more readily adapted and already pre-adapted, if you will, to what you have going. And the less adapted, the more work will have to be done to get the new corn varieties to be adapted. It's all part of the process, finding out what people did and how they did it and what you might want to do. But it is wonderful to see the remarkable work that has been done over the centuries to adapt the same general type of corn, not only to the wet and cold of the St. Lawrence Riverway and the Great Lakes regions, but also to the hot, dry, short seasons of the Great Plains. There's a large number of varieties that were there, largely based on texture and color, very similar in ear type. But you look at these, you'll see that there are some long, skinny ears, but there's also some chunky 12 rows. As you head west into the plains, as I mentioned, you tend to see a higher proportion of larger row numbers, which does help support the hypothesis that maize may have moved from the west into the east, where it was refined into more and more of these thin, faster drying types. However, I don't know if it happened that way or not. That's just a hypothesis. Here's some Fort Peck corn. These are mixed variety that was grown at that reservation after that was settled. I don't think the Fort Peck corn still exists, but again, you can see slightly shorter ears than we see in some of the stuff from the Northeast, but again, a mix of skinny 8s and some chunkier 12s. This corn also has a remarkable story because it did go very far west This sort of corn went up into Saskatchewan. This sort of corn was pushed west into Montana. And a lot of people, even those who migrated quite a bit, sometimes would stop and have gardens for part of the year, or grow gardens and come back to them to harvest, or simply bring trade items and trade from the village farmers to get corn. But corn was a big part of food culture among many different peoples. Corn moved all the way up into the Flathead Valley and beyond. Some of the northern Flint types are actually grown in Washington State and Idaho. So it has moved quite a bit, but again, adapted to short, cool seasons or to some intense heat for part of the season in the case of these Great Plains types. 45 bushels to the acre isn't bad way up in the mountains, I have to say. If you're familiar with some of the beautiful corns that are available commercially, here's Dave Christensen out in one of his cornfields, or a couple of them in this case, showing off Painted Mountain, which is a newer population bred from northern plains types and some others from the desert southwest. So it's very, very colorful, flowery corn, quite adapted to dry, intensely hot, short seasons in Montana that start cold, end cold, but are hot in the middle. This corn can stand up to all of that very, very well. Not always as well adapted to rainy seasons further east, but some of those things from further east don't always do so well out there. So again, adaptation's a big deal, and that's a lot of what farmers have been doing over thousands of years, is adapting their seed to wherever they're growing. And this long dance with the seed and our selections and the weather and all its vagaries from year to year. Varieties recommended for the West in 1936 included still a few. Australian white, don't know why Australian, it's a white flint corn though. Popular down in Colorado and some other locations. Crawford yellow, which apparently has disappeared, and Dakota white, which was a white flint corn developed in North Dakota from existing flinty varieties that the Noita people were growing. There were some other populations from the region. Some are newer in development. Some have been around quite a while. You can find commercially or through government seed banks. Some of the NGOs also have some of these as well. There have been ongoing contributions I would like to point out. Flint corn didn't just up and disappear or go into secret hiding. For quite some time into the 20th century, it was still a part of 4-H programming, which taught kids how to grow corn and how to save seeds. Wonderful to have that happen again. The flint corns were a part of the development of this corn belt dents that we see so ubiquitous in fields today. So most of the corn you see, of course, is these big ears with 14 to 18 rows of kernels, kind of pointy kernels with a big dent on one end. That was developed in part with northern Flint parentage, which helped to adapt varieties that were from Mexico coming into the South, and so brought with it slightly longer ears and some cold tolerance, probably some beneficial flavors as well. But the Corn Belt dents developed in the 1800s did include northern Flint in the parentage, and you can still find those genes are present. And of course, today, as the indigenous food sovereignty movement expands, as people of every race and culture are re-examining seed saving and growing their own food, the northern Flint types are certainly a part of this. And so a lot of people are expanding seed supplies and sharing seeds and teaching based on the growing of northern Flint varieties. That's a wonderful thing to see. So the northern Flints are corn. And an important thing to recognize is that corn generally follows this exact same pattern of growth and development. Now, corn is a critically important crop in American agriculture, and Chinese agriculture, and Brazilian and Argentinian agriculture, and European agriculture, in a lot of places around the world. Huge in, of course, all the places where it's from originally, Mexico and Central America and South America. Um, you plant a seed, and at first you get this tiny little plantlet, and one by one it starts to put up leaves, and then eventually things start to happen you can't see, but they're happening. So while these plants are, not quite knee high, they're already making the biochemical determinations of how many kernels will they make, how big will the ear be, how big will the tassel be. And then the plant starts to expand further, and we get into the reproductive cycle where the tassel appears at the top. This is true of all corn. It's a determinate plant. Once the tassel appears, it's no longer growing. It's going to reproduce. So first the tassel appears, then the ear shoot, the silks appear, pollination takes place, the kernels develop. The plant then begins to die. It senesces, as they say in academia, and it starts to dry down. All corn follows the same basic pattern. However, the timing and everything depends on, the type of variety that you have, how tall it is, and the rest. How you manage it is important, though, to recognize these developmental stages. Early on, all corn needs to have the weeds removed, and the more you get after those weeds while the plants are less than 3 or 4 leaves in height, the stronger it will be. It actually makes a difference. By the time there's starting to be 4 to 7 or 8 leaves, they really need to have fertility. And so whether you're side dressing or building an organic type of fertility into the soil, it needs to be present at that time so that they will try to develop large ears and start to initiate many different kernels, so you'll have a higher yield later on. It also allows the plant to vigorously grow and to begin to outgrow any remaining weeds that you haven't already hoed away once the plants start to shoot up. Traditionally, corn would be weeded at least twice. Once when it's quite small, and another time just before it's too tall to work through anymore. And after that, you could mostly leave it go. It would take care of the weeds itself. Depending on your situation, that might work, or you might need 3 or 4 times of weeding or something else, or you might want to grow with pumpkins, which can help with weed control later. A lot of different ways to go at it, but the plants follow the same pattern. And when you talk to scientists, they will oftentimes use this lingo at the bottom where we've got germination, we've got emergence, and then these vegetative stages named by the number of leaves that are present, and then these reproductive stages based on what's happening to the kernels, R1 through R6. Ear shank is a big deal in corn. If the shanks are very, very short, the ear will be tight to the stalk, and when it's dried down later in the season, it will tend to be fairly upright. If you're in an area that's dry, or you don't get a lot of fall rains, or if you have very, very good husk coverage, that can be fine. However, ear shanks that are a little bit longer and thin and tend to bend over when the plant senesces will help the ear tip downward so that the husks provide rain protection and any rain runs off. That can be very, very important if you're going to leave the ears on the plant to dry, if you don't have too much raccoon damage or if you're not braiding. Ear shank can also be too long. I have seen shanks more than 1 foot in length, believe it or not. So 1 inch long to a foot long. The foot long ones almost certainly will bend down as the plant matures that ear. And if the ear isn't that high off the ground, it might very well touch the ground, in which case, give it a week and it will start to mold. Or give it a night and the raccoons might very well find it before you do. So depending on your purposes, the height of the ear and the conditions, ear shank length can be an important issue to consider. So watch what's happening with your varieties and consider what choices you might want to make. Here is an ear of commercial dent corn that has a relatively short but thin shank, and at maturity the shank bent right over and the ears just hang there, and the rain falls off if it gets rain later. So that can be a very helpful thing in places if you're going to leave the corn in the field and you're going to let it dry there. Diseases are of concern with corn growing. There's concern with every kind of plant as far as I have seen. And corn can get many of them. Some of them are not unusual up north here. Northern corn leaf blight is not unusual. Common rust is pretty normal. There are new things coming in like tar spot, gray leaf spot, Goss's wilt. Southern rust, thank goodness, we don't have too much of, but that's also coming north. So as the climate's changing, more diseases are coming north. We've had others for a very long time that do well in cool conditions. Unfortunately, all of the northern Flint varieties are not particularly tolerant of all of these diseases. And they're frequently not tolerant of any of the southern diseases. So as those move north, they might be a threat. Having the leaves come off before the ears are matured means the kernels won't get as big or be as full. The plants will die before full maturity. So that can be an issue for yield and health of the plants. So it's important as you're evaluating things to consider what diseases are showing up, and if you're really going to get after this, mark the plants that have them, detassel them maybe before they shed pollen if it's an early developing disease. Notice the ones at harvest time that have rusty leaves or leaves with some other lesions. Eat ears from them, but don't save those seeds, perhaps, would be a consideration. As far as the future goes with other things coming north, don't know what to tell you. Generally, the northern Flints don't have very much tolerance of any of the southern diseases. Ear rot is a big problem. It's one reason why people sometimes rush harvest a little bit. Get those ears off the plants, get the husks off the kernels, and hang them to dry in a place that's warmed. Hanging them in a braid from a rafter or a pole over an area where warm cooking or heating is happening. It's been an important thing for a very, very long time. Part of the reason is this. In some cases, molds will get in and absolutely spoil those ears. You don't want to save any seeds from ears like this. None of this is fit for human consumption or even animal consumption, quite frankly. Back to the soil it goes, but not in your garden in case any of those might spread. But watch for these. You don't want to save seed from them. You don't want to eat those. And a plant that has tendency to get ear rot might be a plant where even if part of the ear is healthy, don't save any seeds from that. Try to avoid that sort of thing if possible. Other things to look for as we grow the plants. Here we've got some dent corn on both the left and the right. Even with prop roots, sometimes in certain conditions, the corn will still root lodge, where we get great leaning right from the ground. So more than a 30% leaning from the ground is called root lodging. That tends to make it harder to pick the plants, makes them more likely to actually tilt all the way, puts the ear down closer to creatures like raccoons or deer. On the right, we have stalk lodging, where the stalks stayed upright, but they broke below the ears after maturity, broke pretty badly. And as you can see, a lot of those ears are, again, close to the ground or touching the ground. At this point, they're hard to harvest. They might not be worth harvesting. A lot of them will already start to mold. Mice will be getting after them, squirrels for sure. Generally, in corn breeding, we like to have the plants stay upright until it's time we can harvest. And we tend to select against those plants that don't do that as well. And of course, make your choices for what works for you. Everyone's got a different system. A huge thing people consider is yield and yield potential. Now, yield is touchy because yield is dependent upon so many things. It's the totality of everything this plant has done this season. All of its root growth, how much sun it got, how much rain did it get, what kind of fertility did it have, which genes were kicking on and off, what pests or diseases attacked it, what's its inherent capacity to yield if everything's good. All those things come into play in this huge dance of genes and our management and whatever nature brings this season. So it's hard to really pin down yield definitively without a lot of testing over multiple sites, multiple years, to really get a feel for what a variety will do under all these different circumstances. However, you can, do some preliminary things and make some cutoffs. At least if you're screening varieties, if you've got varieties that are at least okay to seem pretty good, good chance those are okay to pretty good. If they look just dreadful this year, well, maybe those aren't worth playing with anymore. And so even if you can't assign a number to the yield, maybe their yield potential isn't that good. You can use various techniques to estimate yield based on ear counts and kernel and counts and how many kernels and the weight of the kernels and such. There are techniques to do that. So you can come up with an estimate of how many bushels could be produced, because in the end we are producing food and people need an amount of food. So you can use calculations like this, even with small plots, to estimate yield, which is kind of fun sometimes. It doesn't mean that's the kind of yield you will always get, as I just explained, but sometimes it's interesting just to get a preliminary feel for where things are going. There are some other very interesting things to look at as far as the diversity of maize, and when you work with old, unimproved, which is basically science speak for not intensively selected in a big way. You look at populations that still have this landrace characteristic with lots of genes floating around as very diverse populations. You will see many of the different mutants that are known in maize. Now, mutants sometimes gets a bad rap, used a lot to mean something scary in science fiction films. Mutant genes are everywhere. All of us have mutant genes. Everything has mutant genes. The idea is basically the original wild type, whatever it was, over time has accumulated lots of different genes, some of which work and some don't work. When they don't work, they're called recessive. And when you get two of them, then whatever that trait was gets turned off. That can be a problem, but a lot of times not that big of a problem. Some genes are dominant and they make something interesting happen. Sometimes it's very useful, sometimes not so much. There's an incredible amount of time you could spend learning the genetics of maize because it's an important crop. People really put some effort into it, such as this book from about 30 years ago, just listing all of the known mutants from maize and which chromosomes they're on and what the traits are like and how they work. Likely you'll see some of these as you work with some of our old land races of northern flint corn. And here's a few just to watch for. There are a number that can show up from time to time that affect the ability of the plant to make chlorophyll. If you know about plants, chlorophyll is a big deal. And so if they can't make much chlorophyll, they're not going to grow very well. So the absolutely white ones and the mostly white ones, those will grow for a while, and when they run out of seed food, they'll die. Others have traits that will get them through for a while, or they might kind of come around later. Um, a lot of times those will yield okay, not as well as they might. And then, of course, if they've got full function, they can do whatever the plant is capable of doing. They'll harvest that sunlight and turn it into food. Here's an example from my garden this year. Here is a selfed line. So exposing recessive traits. The plant on the left in the center has full chlorophyll function, and it's growing very well. The slightly shorter one, which is a pale green, has a trait we call virescent. Virescent plants will oftentimes be very pale green going into the summer, and then they'll kind of come around later and still produce a little ear. Not very productive generally, so this is a trait people frequently select against. So to select against it, of course, you could kill that plant or just detassel it before it sheds pollen, because you'll see this early on. That'll be a way to take its effect out of the population at large if this is a concern. If you find it beautiful, then of course there's just some lovely diversity in colors as the garden grows. Slightly less useful is defective kernel traits. There are quite a few of them. And with defective kernels, you'll see a kernel there. It's obviously not filled out. They're kind of funny shaped, usually very small. Their weight is quite a bit lighter than the full kernels. If you plant them and they do germinate, they make weak little plants. This is a recessive trait that's definitely not useful. Reduces the harvest of food and makes for plants that aren't really easy to grow. So defective kernel traits are mutants that are frequently selected against. If you see an ear that has these, you might select against the entire ear, or certainly you wouldn't save any of those for seeds. There are other interesting things that happen. Sometimes people love them. Sometimes people don't like them. This is a trait called fasciated ear. The tip of the ears within the set of husks, so this is all one ear, but the tips divide into multiple ears. And generally it's a disaster because it opens up the husks in a way that allows bugs and birds to get in there and or rain. However, sometimes people really like this, and on the right is a popcorn variety called Bear Paw that has this trait, and it's a very old variety. People have kept it for centuries, most likely. So sometimes you like it, sometimes you don't. But you might very well find this on occasion. This is a different trait. So this is not divided at the tip of the ear. This is an ear within the same set of husks that has several narrow wings to it. Each of these has 4 rows rather than the normal 8 or 10 or what have you. In this case, wings can have various numbers. Just like the fasciated ears, they tend to open the husks a little early. Sometimes that can be a problem. A little bit harder to dry down. But interesting to see. It's basically the ear trying to act like a tassel by having these branches. Another thing that can happen is multiple ears on the same shank. So all of these ears have their own husks. They are separate ears, but the shank is in fact a branch. And sometimes there are those that will have the ability under certain circumstances to grow extra ears on these little branches that the ear shanks represent. Sometimes those will form and actually grow kernels. Most of the time they won't develop very far. Sometimes you'll get multiple ears on the same plant. Many of those also don't actually get formed fully. But on some rare occasions, you have a plant big enough that you'll get 2 or even 3 ears on the same plant. But these are on the same shank as opposed to the same stalk. But just remember, there are interesting mutants, beautiful mutants, like all these color mutants that you see in this glass gem or in this painted mountain. All mutants aren't necessarily bad. Some of them are really fun, and it's a wonderful part of this dance with these land races as we grow them and keep them and decide which seeds to save and which ones to eat. So welcome to the world of northern flint corn. I hope this brief introduction was fun and helped get you going on a great adventure in your life. You will become a seed saver if you spend much time with them, and then the decisions made and the management made as you dance with this garden partner throughout your life, that will become an important part of what you do and share with others. So I hope you have a wonderful time with it, and I hope this helped get you going. If you want to contact me for additional information or to tell me how great your project's going, I live here in East Central Wisconsin. I can be contacted via email at the college, and also my personal email is dakotacornman@yahoo.com. Thanks so much for listening, and I hope good things come your way.